Hi, welcome back to Common Core Algebra II. Today's lesson is 12.3, adding probabilities. So there are times that we want to determine the probability that either an event A happened or event B happened. To do this, we need to be able to account for all of the outcomes that fall into either one of the two events. Let's see how this looks given a simple Venn diagram. So in exercise 1, consider the spinner shown below that has been divided into 8 equally sized sectors of a circle. The spinner is spun once. In this experiment, we will let A be the event of landing on an even. So why don't we underline that? Let A be the event of landing on an even, and let B the event of landing on a prime number. So basically, A, so I'd like to even spend a little bit more time saying A is equal to an even number. So it's going to be 2, 4, 6, or 8. And B is going to be a prime number. If you remember, the first prime number is a special number. It's 2 because it's the only even prime number. 2, 3, 5, 7 are my prime numbers. So in a Venn diagram, we're going to have event A and B. Let's see, what do they have in common? They have 2 in common, and that would be it. So the 2 goes in the middle, and then we have 4, 6, and 8 in A, and we have 3, 5, and 7 in B. 2 is what they have in common. So we call that the intersection. So when we have 2 or more sets and we can talk about their union, which is like when 2 people get married, it's everybody together, and their intersection, which is what they have in common. So that's basically what's defined for you here in this box. So the union is everybody. And again, if we have a list of 2 sets of groups that are going to a wedding, if you have people that you have common friends with, you're not going to set 2 places for them. You're only going to set 1. So we're not going to repeat any of the numbers in that intersection. All right. And the intersection here, this just shows this middle section that they cut out right here. So that's what the intersection is. That's just what they have in common. So exercise 2. From exercise 1, write the following 2 sets, A or B, which is the union. So sometimes we also write that as A or B, like this. So A or B is everything. So it's going to be 2, 3, 4, 5, 6, 7, and 8. Now this is a set. It doesn't necessarily have to be in order. And notice how I didn't repeat the 2, even though it showed up in both sets. All right, so if you're making a list of the people going to your wedding, you're not going to include Uncle Frank twice. You're going to just include him once because he's not going to take up 2 seats at your wedding. All right, so A and B is sometimes written like this, and that's just the intersection, the common elements that they have in common, which is just going to be 2. Now in exercise 3, from exercise 2, why is the equation n, the number, that means the number of A or B, equal to n of A plus n of B? Not true. So why is this not true? Because we know the numbers of A or B is going to be what? We just figured that out up here. How many are here? 1, 2, 3, 4, 5, 6, 7. So this is 7. And why is that not equal to the number of A plus the number in B? Well, we have to go back and look at what that looked like back here. So the number of A, whoops, that's not here. Is it up at the top? Oh, yes, it was in the Venn diagram. Here it is. So how many did we have in A? We had right here 1, 2, 3, 4, and then in B we also had 4. So now we can go back and say this is not equal to 4 plus 4. So why are they not equal? Because they're considering in this problem here that number 2 is being repeated in both sets. Two-way frequency tables or charts give us a great example of how events or sets can combine, union or overlap, intersection. So let's take a look at exercise 4. A small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of 4 events. So they're either going to be male, female, going to college, or not going to college. All right, so now it says give the values for each of the following. Okay, I'm going to slide this up just a little bit. Now the number of males. So if we look here and we see the number of males, we're looking at the total number of males, whether they're going to college or not going to college. So that's going to be 30. Do you see where that is? It's right down here. All right, so then they go, the number of females right next to it is 22. The number of people going to college, male and female, 29. And the number that are not going to college is 23. Now, take a moment and just see where those numbers came from. So now the second one, in number 5, it says the number of male and going to college. So the number of male, which is right here, and the number going to college, which is right here, would be 16. The number of females and college, so females and college, is going to be 13. And the number of females or college, so the number of females is 22. The number of people going to college is 29, but we have to pick out we only have to take out the elements where they're female and going to college. So the females and going to college is 13. So we have to subtract out the 13 to get our final answer of 38. Right, so just to clarify this is the number of females, this is the number going to college, this is the number of both. What is the probability that a person picked at random would be a female who is going to college, represent using either union or intersection? So in this case, we're going to have the probability of a person picked at random be female who is going to college and going to college is equal to, now let's just take a look at our chart again. How many females are going to college? Right here, 13. So we can say 13 out of 52. What is the probability that a person picked at random would be a female or someone going to college? So so it's going to be, all right, so this one we're going to have the probability of F or C, which actually we did right up here. And the number was 38 out of the total, which is 52. So D says explain why that's not true that we talked about. Now here we have to use some words if it's using the words explain. So here I want you to take a moment and explain that when you talk about the number here or the probability here, it can't equal this probability because once again you need to subtract out the probability of both. You need to subtract the probability of both occurring. So take a minute and write that down. We'll discuss that tomorrow, what you wrote down. And over here, the general law or rule is the probability of A plus the probability of B minus the probability of A and B. So write down what you need to and meet me at exercise 5. So sometimes we don't always have to use the formula. Sometimes we can just use a little common sense. So in exercise 5 says a standard 6-sided die is rolled once. Find the probability that a number rolled was either an even or a multiple of 3. Represent this problem and the sets using a Venn diagram. So if you think about a Venn diagram, here are my even numbers. Here are my multiples of 3. So my even numbers are going to be, remember, my whole set or my universe is going to be 1, 2, 3, 4, 5, 6. So sometimes when we think about this, we also put a box around it that will incorporate all of the numbers. So number 1 is neither. So I'm going to put a 1 here. 2 is even. It's not a multiple of 3. 3 is a multiple of 3, but it's not even. 4 is even, not a multiple of 3. 5 is neither, so I'm going to put a 5 out here too. And then we have 6, which is probably the only thing that we have that's in common. So that's what our Venn diagram looks like. Now it says verify, it says represent this problem as sets, even though you don't need to verify the probability addition rule from exercise 4. So what they wanted us to do is the probability of an even number or a multiple of 3 is equal to the probability of the even number plus the probability of the multiple of 3 minus the probability of both. So what's the probability of an even number? Well, I have 3 even numbers out of the 6. What's the probability of a multiple of 3? I have 2 out of 6. And what's the probability of both? Just 1 out of 6. So here is 4 out of 6, which I think you probably could have figured out without using the formula. All right? Because the 6 doesn't repeat. I think very easily you could say, well, I had 6, and I have 1, 2, 3, 4 of these. So our last problem is exercise 6. Try to keep this under 15 minutes, which I know you always like. So sometimes this is unavoidable using the formula, but insurance companies typically try to sell many different policies to the same customers. One such company, 56% of all customers have car insurance and 48% have homeowners insurance. 18% have both. A customer is picked at random. Find the probability that he or she has at least one of the policies. So here we want to know the policy of, let's say, car insurance or homeowners insurance. So that's going to be the probability of car plus the probability of homeowners minus the probability of both. Now, again, we here in math, we deal with numbers. So it's going to be 0.56 plus 0.48 minus 0.18, and we get an answer of 0.86. Now, since they gave it to us in percentages, we're going to give it back to them in a percentage. So I'm going to say 86% have at least one policy, one of these policies. Now, this one is great because this one says, which one has neither of these policies? So if they don't have, if it's like the opposite of having one or the other. So what they're asking for here is the complement. Without using the word, they're saying, what is the complement of having one or the other? And that's simply going to be 1 minus 0.86, or you can do 100% minus 86%. Either way gives you either 0.14 or 14%. Have neither of these policies. Okay, I have about 12 seconds. So, you know what I'm going to tell you, to always make good choices and be safe. See you tomorrow.